Paul Dirac said that all matter and energy exists as both particles and waves.
And that goes for electrons, too.
Niels Bohr's classic model of the atom was familiar to science students everywhere. Electrons spinning around the nucleus like a tiny little solar system. And young scientist Werner Heisenberg didn't like models at all. He didn't even believe atoms were things. He thought of them more like a secret code.
If an atom can't be seen, it's not a meaningful concept. Your atom is boring, Niels Bohr.
Then, in 1926, Austrian physicist Erwin Schrödinger came up with a new atomic model that consisted of standing wave patterns around the nucleus.
I have found an equation that can be applied to any physical system in which the mathematical form of the energy is known.
So when Max Born came along with even more mad math skills, no one quite knew what to expect.
The wave function itself encodes all the information about the particles that can be determined through observation.
Right. In other words, using Max Born's equations, Bohr's orbits were now replaced with dark smudges where electron orbits might be found.
These are all the places the electron could be at this exact moment.
Born had found a way to reconcile particles and waves by introducing the concept of probability.
This is not probability due to ignorance. This probability is all we can ever know about an atomic system.
That's insane! What do you mean by probability? You're wrong, and I can prove it! Imagine for a moment sticking a cat in a box with a radioactive nucleus, which has a 50% chance of triggering a mechanism that will drop a hammer, breaking a flask of poisonous fumes and killing the cat. According to your matrix calculations, Max Born, the unobserved nucleus is a superposition, meaning it exists partly as decayed and also partly as undecayed. That's like saying the cat in the box is both dead and alive, which cannot be true. Ah!
Silly boy. Until the box is opened, the cat is both dead and alive. It's your act of observation that collapses the two quantum states into a single one.
Say what?
Open up the box and look inside.
He's alive.
100% alive. 0% dead. Your observation confirmed it.
Observation has always played a key role in science. Galileo spent his whole career demonstrating proper testing of theories through observation and measurements. But from now on, at least in the world of quantum mechanics, the very act of observing would have a direct effect on the thing observed.
Look at it as a wave, and it behaves as a wave. Look at it as a particle, and it behaves as a particle. I am now a believer of this new probability theory. In fact, I'll be so bold as to say that the description of any atomic state before observation is undefined. It has only the potentiality of certain values with certain probabilities. And my uncertainty principle states that the more precisely the position of a particle is determined, the less precisely its momentum is known.
So, it was no longer possible to say with any certainty that every cause had a clearly defined effect. But that was okay, because as time would tell, all sorts of things from transistor radios to atomic energy to space travel and microchips would prove that quantum physics actually worked, but that the only certainty in this quantum world was uncertainty itself.